In this video, we will be learning about coterminal angles and reference angles. As always, it's important that you have memorized at least these three key trig functions. The ones shown here in yellow have to be on instant recall in your brain. So if you haven't memorized these three, pause the video right now and memorize them. Once you know the three ones in yellow, you should be able to write down all six, because you'll notice that the cosine of pi over 4 is the same thing as the sine, so you can write that down real fast. And hopefully you'll realize that the as we go from pi over 6 to pi over 3, these are just reversed. So if you need to know the sine of pi over 3, that's going to be the same thing as the cosine of pi over 6. So just cut and paste that up there. If you want to know the cosine of pi over 3, that'll be the same thing as the sine of pi over 6. So memorize the yellow ones and the white ones will follow. So as you begin any test, quiz, or assignment about trig functions, the first thing you should do is write these six down on a sheet of scratch paper or something. So for the rest of this lesson, we're going to refer back to this as fact. Alright, so we're going to do these three problems right here. For each one of these angles, we need to find a coterminal angle between 0 and 2 pi, and we need to find a reference angle in radians. And of course, to do this, we're going to do a sketch, and it should be easy to know what the quadrant is. So let's get started. Alright, when you're talking about coterminal angles, you are talking about adding or subtracting 2 pi to get yourself into this zone. So this is a negative angle, so clearly we're to the left over here somewhere, and we're trying to get from below 0 up into the range between 0 and 2 pi. So clearly we need to add 2 pi. Now before I do that, understand we need like denominators. So we need a denominator of 4. So you can think of it as multiplying the numerator and denominator here by 4. So that's going to make 8 pi in the top, so 8 pi over 4. So that's what we're going to add here. And so that's going to make negative 5 pi plus 8 pi is 3 pi. Get this out of the way. So we're going to have 3 pi over 4 at that point. And 3 over 4 is 0.75, so this is the same thing as 0.75 pi, and I'm only mentioning that to show you that it is less than 2 pi. So we are now between 0 and 2 pi. So this is our coterminal angle. So far so good. Now we also need to do a sketch. So let's do that. So here is our, well, let me just draw it as a circle. Okay, so here's our sketch of a unit circle. Alright, now here's pi over 2, here's pi, you get it. So the original angle was negative 5 pi over 4. Alright, pi over 4 is a special angle, so the way we handle that is if we're dealing with a reference angle of pi over 4, we draw some reference angles of pi over 4. So if I split this like this, see how there's 4 angles in the top? That means each one of these is pi over 4. So we are supposed to go negative 5 pi over 4. The negative direction is clockwise. So starting from the positive x-axis, if I go clockwise, I'm going negative pi over 4. So this is negative 1, 2, 3, 4, 5. So this would be a picture of negative 5 pi over 4. Okay, so there's my sketch. So clearly that puts me in the second quadrant. So that's quadrant 2. Now the reference angle is just going to be pi over 4. And that's the way it's going to be for any special angle. When I talk about special angles, in degrees, I would be talking about 30 degrees, 45 degrees, or 60 degrees. Pardon my yawn. But in radians, that's pi over 6, pi over 4, and pi over 3. Pi over 2 is a little bit different. But if you see any of these denominators, 6, 4, or 3, you know that the reference angles will simply be pi over 3, pi over 4, or pi over 6. So, as soon as I saw that this was over 4, I immediately knew the reference angle would be simply pi over 4. So when you look at the sketch, of course, you can see the reference angle right there, and it is in fact pi over 4. Okay, let's move on to number 2. Now this is not one of the special angles, so we will have to approach this slightly differently. First of all, 13 over 10. Let's see how that compares to 2 pi. Alright, so if we do 13 divided by 10, alright, of course that is 1.3. And the thing about that is, if you understand that this is equal to 1.3 pi, then this is already less than 2 pi. And specifically, this is already between 0 and 2 pi. So we don't need to add or subtract 2 pi. So what we will do is just copy this down unchanged. So 13 pi over 10, it'll be its own coterminal angle because it's already correct. So let's just move on from there. We need to draw a picture of 13 pi over 10. So let me just write this in the corner to remind us of what we are doing. So here comes a sketch of 13 pi over 10. Okay, so again, this is not a special angle, so we have to be careful how we sketch it. So there's our x-axis and our y-axis, alright? So this is pi over here, so this is like 1 pi, if you will. Right here, this is half of pi, so as a decimal, this would be 0.5 pi. Okay, and down here, this is 3 pi over 2. You could think of it as pi and a half, so 1.5 pi as a decimal. Then if I went all the way back around, I'd get to 2 pi if I went a full circle. So the thing is, we are starting from the standard position, positive x-axis. It's positive, so we're going to go clockwise. And remember that this is equal to 1.3 pi. So that's where we want to go. So if I rotate in the positive direction, see what I've got. So that's 0.5 pi. This is 1 pi. Alright, now if I went around to here, that would be 1.5 pi. That would be too far. So I don't want to go all the way to 1.5 pi. So that means I'm going to stop somewhere in this quadrant, the third quadrant. Okay, so as far as sketching the angle, I'm going to let it go to here. And so this would be a picture of 1.3 pi, 13 pi over 10. So there's my sketch. Clearly that puts me in the third quadrant, so let's go ahead and mention that, because that's what goes in that box. But over here we're supposed to say the reference angle. Now the reference angle is always measured here between the x-axis and the terminal side of your angle. So my reference angle is this guy right in there. Now understand that you know, my angle here, this terminal side is what we were shooting for. This is 13 pi over 10. That's what this is. So hopefully you'll see that the reference angle is between these two guys. It's between 13 pi over 10 and 1 pi. So what I need to do is subtract those two, and that'll be my reference angle. The reference angle will always be positive. So let's see, 13 pi over 10 minus pi. So here we go, 13 pi over 10 minus pi. Well, I need like denominators, right? So I need to make this denominator 10, numerator 10. All right, the 10s would cancel. So this would be the same thing as pi. But now I have like denominators. So I've got 13 pi minus 10 pi is 3 pi. So that's 3 pi over 10. So 3 pi over 10 is the reference angle. Alright, let's do one more example. This is negative, so clearly we need to add to get into the zone between 0 and 2 pi. So I'm going to add 2 pi to this. Adding 2 pi. Now, this is like having 2 pi over 1. I need a denominator of 6 though, so I'm going to multiply by 6 in the top and the bottom. So in that case, what I have going on is negative pi over 6 plus, alright, 2 times 6 is 12, yeah, so that's 12 pi over 6. So it's like negative 1 plus 12. So that's going to be 11 pi over 6. So that will be my coterminal angle, 11 pi over 6. Okay, great. Next we need to do a sketch in this box. Keep in mind that this is a special angle. Alright, it's pi over 6 is one of those special angles. So the way I do a special angle is I like to draw the special reference angles. Okay, so here I've drawn pi so far here in the top. If I split that again right down the middle, then this is pi over 2. Alright, each side is pi over 2. Now I need to make this into 6 pieces for pi over 6. So I'm going to take each of these and split them into 3 pieces. So that's a little bit tricky to do, so I'll just be as careful as I can. Okay, so now I've got 3 pieces up there. I need to do the same thing over here, so I'll have a total of 6. Alright, doesn't have to be perfect. Alright, so there I have 6 parts in the top there. So I need to move negative 1 pi over 6. So I'm moving in the negative direction, so that means clockwise. So I will start out in standard position, positive x-axis. If I'm moving negative 1 pi over 6, that means I'm moving like this, just one of them. So that would make my terminal side right here. So this would be a picture of negative pi over 6. So there you go. In this column we're supposed to say what quadrant we're in. So clearly this is the 4th quadrant right here. So kabam, 4th quadrant. And because this is one of those special angles, we don't have to think about the reference angle. It's immediately going to be pi over 6. Alright, 11 pi over 6, pi over 6. Alright, negative pi over 6, pi over 6. Okay, so that's it. I mean, if you look at it, you can see the way we drew this, each one of these is pi over 6, including the reference angle here. This would be the reference angle, and it is, in fact, pi over 6. So, that's going to do it for this video. Here endeth the lesson.